let's go. Welcome. The weather forecast promised me sunshine, didn't happen. But I took out my Hawaiian shirt anyway. So, my name is Chris Thalinger. I work at Twitter. I'm part of the VM team, so we have a small VM team at Twitter. And if you're going to tweet about this talk, please include that hashtag, so give a little love back to the VM team back at home. And so this talk is, I've been giving similar talks like this for the past 2 years or something, and it's all about the Graal compiler. And so in this particular talk, the goal is 2 things. One, and that's the main reason why I'm giving these talks, because I want the compiler to have some exposure. So what I want you to do is to give it a try, right? So if you're going back to work on Monday, maybe think about just trying it out and see if it works for you, if it's better for you. The goal for Twitter in all this is to save money. So if we can, by using a different compiler, if we can reduce CPU utilization or anything like this, and since Twitter is a big service, you can save a lot of money. So this is what this is about. Probably everyone here knows what Twitter is. It's a huge distributed system. We have many, 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 many microservices. I don't even know how many, but a lot. And then there are, like, one of the main services we have is the tweet service. That's basically reading and writing a tweet. And then the user service that does everything that what your user has, data associated with it. And then the timeline service, which produces your timeline when you scroll through your timeline. And the social graph service is basically the graph between your followers and followers, following people you and the other way around. So these are kind of the main ones, and also the biggest services we have. We have many JVMs per service. We have thousands of machines running thousands of JVMs, and we do that in multiple data centers. So it's a big system. So every tiny little bit you can save multiplies, and then that amounts to a serious number in dollars. We do a lot of open source, so Twitter is very dedicated to open source. Internally, we use a lot of it, and we also give back to the community. You can go to this link. It lists all of the open source projects that we've been open sourced, and in all this Twitter ecosystem, basically, Graal is a very good fit because it's open source too. And we are also contributing back to the Graal project itself. We also have our own JDK, basically. It's based on OpenJDK 8U. We have a bunch of changes in there, like obviously we've backported JVM CI so we can actually run Graal on 8. JVM CI, so chapter 243, we've done for OpenJDK 9, and it's now 9's released. When I did the slides, it wasn't released yet, but now it's released. So if you download Oracle JDK 9 or OpenJDK 9, you will have JVM CI in it, and then you can just grab Graal from upstream, from GitHub, build it, and then run it with OpenJDK 9. We've backported it because we're still on 8. Our OpenJDK build also includes Graal itself, so it's easier for us to build it. Then we have something that's called Contrail, which is like GFR, and now that Oracle is open sourcing GFR, that will probably go away at some point. We might contribute stuff back that we did over the years, but that's it. And we have the team we have at Twitter. We have 4 VM engineers, so there's 3 GC engineers and me, the compiler guy. And so we have a bunch of GC optimizations, and mostly for CMS because that's the collector we use the most. So why Graal in general? Because the JVM runs fine, right? Yes, on the outside it does, but for us on the inside who are working on the compiler, it's a pain every day because C2 is very old and very complex, so it takes multiple years to really understand what the compiler does. And the problem is if you touch the compiler over here, something over there will break. I mean, you can ask Volker about this. He's working on that stuff for many, many years. So it's a pain. And over the last couple years, I would almost say, there were no real major optimizations, like new optimizations. We have C2 has escape analysis, and it has inlining, and it has all that. But there were no additional improvements in that area, and like no new implementation of register allocation or anything like this. The only the only optimizations that were done more or less were mostly driven by Intel, and they did a lot of intrinsic optimizations, like handwritten assembler code for string operations, or for there were a bunch of cryptographic intrinsics done and things like that. So no real compiler work. And if you ask me personally, I think that it reached its end of life many, many years ago. But you know, that's my opinion. I also think, and if you ask people who have used Graal and worked with it, that it's much easier to understand. And it's because it's very modular. Like it's been designed from ground up to be modular. When I say modular here, that doesn't really mean jigsaw. It means everything's neatly organized into packages, right? You have packages. You see the whole list of packages here. You see there are a bunch there called. It's kind of an old screenshot. It's not called com Oracle anymore, but you see all these, like there are hotspot packages, and then there are some that actually list the architecture, like Spark or AMD64. So, and then there are some that are not, and you don't have circular dependencies. And the ones that don't list architecture are basically they work on all the architecture. So it's neatly organized. And one of the big things, it's kind of like way down here, but it has better inlining, and it also has a better escape analysis implementation. And that's very important for the slides you'll see later. So I started this roughly a year and a half ago at Twitter. So no one before has, as far as I know, no one has ever used Graal in production, like at a big scale, right? Maybe there might be a company out there somewhere that was using it in production. I've never heard of them. So one thing that I wanted to do, as I said earlier, I think it needs exposure. And when I say that, C2 became such a good compiler because so many people were using it, right? Oracle or Sun, they could only test, or they only had so many tests, right? What you really want is millions of users, you know, throw their 10-year-old Java code onto the compiler, and then you'll see if it holds up or not. And so this is what this compiler needs too, obviously, to become really mature. So that was the main motivation to do this at Twitter, to see if it's really production ready or not. We found a few bugs, but basically only the ones that I think I'll list 4 here, if I remember correctly. These were the only ones we found. So the first one was there was a method, and it complained that it couldn't compile it. It couldn't do OSR compilations. I'm not going into detail what that is, but the exception looked something like this. It said, "Oh, okay, I can't do an OSR with locks. It's not supported." It was not that big of an issue. So I discussed this with someone from Oracle Labs, and the reason why it's not a big issue, one was it was not a really important method, so I was all right. And then number 2, we were, or are still running in tiered mode, right? We're just swapping out C2, C1 is still there. So if you have something like this and it bails out for a bunch of times, then the JVM will say, okay, I'm not compiling at tier 4 anymore. So just fall back to a lower tier, and C1 will compile it. But it would still be good to have that fixed, right? So the bug is technically closed. No, it's technically still open. The bug is closed. It was fixed by this commit, which I actually didn't know because the bug's still open. But I found out later that it's actually fixed. The bug is still open because when I later then tried to run the same service, I saw a bunch of other exceptions coming up. They were similar but different. And so it turned out, especially for the first two at the top, that it had to do with some static class initialization issue. So what it tried to do is to access static fields, but since you're compiling that right now, so the issue is you can't really access final static fields at that point, right? And so you would have to compile it in a way that you de-optimize as soon as you execute the code, so the compilation would immediately go away, and there would be no point in doing it. Turn out that C2 has some special code that takes care of that. And so that's kind of the method in C2 that does that. And basically it says, oh, I'm the class initializer. It's OK for me to access these fields. So it was just some logic that was missing in Graal. And it was added, excuse me. It was added under this bug. It was only, you see, one changed file, 31 lines. So that was kind of a small one, but it was still important to fix it. Then we had a crash. The problem with that one was it took a couple days to happen. So I was starting up a Twitter service. It was running for a couple days, and then suddenly it crashed, and we didn't know why. And then I was looking around and I'm trying to find the cause. And we are using something called Heapster. It's doing heap profiling. So basically, it instruments code to do the heap profiling. And it turned out that instrumentation, since you have to instrument the new bytecode, and you have to remember Graal is written in Java, right? So everything you annotate, and Graal is obviously also using core library methods. My voice is really getting worse. Sorry about that. There can be issues. And in this particular case, it had something to do with the double value off method that was used in the snippet. A snippet is something, it's a special construct in Graal. It's like an intrinsic. It's handled a little differently. It's basically Java code. It's used like at DSL. It's never executed, but it's being parsed by Graal and then compiled to an intrinsic. That's basically a snippet. And so you can read all this. It's all in the bug, right? So they're discussing a little bit what should be done, and then at the bottom he says, I think it's time to bite the bullet, which then resulted in a pretty big change, right? I mean, it's 2,700 lines of code being added, but since then it just works fine. It was just an assumption that Graal made or never thought would happen with an agent, and in this particular case it did, so that's fixed now. Never happen again. Then, I think that's the last one. No, bug 3. We'll see. We were seeing, there was this one service I was trying, and then, thank you. I was looking at the log file, and the log file was growing like at an outrageously fast pace. And I saw it's like throwing a connection exception all the time. And I wasn't sure where it was coming from, right? It could be anything. It's like in a microservice environment, if a service throws an exception, a connection exception, it could be anything. It could be the service itself. It could be the other service it's trying to talk to. So I I did not know what to do at that point, to be honest. So I thought, okay, sometimes you have to let things go and do something else in the meantime. So I decided to run the Net4 test suite. Most of our services use Net4. And so I was running the test suite, and it turned out, oh, the buffer ones are failing. Okay, so let's see what this is about. And this is a very interesting bug, actually, because it's about the byte swap. And I think it's called reverse bytes or something in the API. It's basically swapping the byte order, right? And so there was a bug with that snippet or intrinsic, and it, for whatever reason, I still don't know until today why, but it only showed up there, right? This is being used all the time. But it only showed up in that particular method, and it only manifested there. It probably had something to do with the graph shape or whatever. So Tom found the bug. He said, oh, yeah, that's an easy fix. It was an easy fix. We had to change 5 files, 68 new lines of code. But that was all right. Actually, only 50. Yeah, that was it. These were the only bugs we found. And that was, I think the last one we fixed, what's now, October? Yeah, that was more than a year ago. So since a year, we've been running this stuff, and there was no more bugs. We are contributing back a little bit. This is still work in progress because I get sidetracked all the time. But the one thing that needs to be done, and I picked this as the first project to do, is JDK 9 has compact strings, and the implementation of compact strings heavily relies on intrinsics because they couldn't get it in C2, they couldn't get it run fast enough with unsafe. So they wrote a bunch of handwritten intrinsics, and they're written in a way that they're only used in C2 and C1. So we have to port them over to Graal. So we're doing this. That's something that I mentioned earlier. For example, you can see there are like SSE and AVX 512 handwritten optimized methods, and most of them were done by Intel. So these were the only optimizations that were done in C2, but we need to bring them over to Graal as well to get to the same performance, right? So this is just a quick benchmark. It's like at the top, that was Graal before, and then at the bottom you see, especially like the third line when the strings are pretty big, that the performance improvement is quite significant. So and at the bottom, numbers, they don't really matter, the numbers, I'm just showing them. The bottom numbers are the same as with C2. So we just have to do that. I'm working on it. I've almost finished it. There's like smaller things missing, but once I'm done with all these conferences, I'll probably get back to it. And the PR is open. Like anyone could pick it up and finish it. Why not? So numbers. So these are now the real numbers that we've found or that we see. Let's put it this way. I was using the tweet service. It's a very important service, obviously, and it has a lot of load and throughput, and it's pretty easy to run. So I was using that one, and it's based on something called Finagle. It's like it's open source. You can look at it. You can download it. I'm no expert. It's like an HTTP whatever something. I think it's built on top of Netty or I don't know. You can send requests and then you get something back. It's a framework for that, right? I don't really care what it is. So that service is reading and writing tweets, right? So if you tweet something in your phone app or on the web, it's using that service. And this service runs 100% on Graal in production. Like every tweet you read or write goes through code that was compiled by Graal since 4 or 5 months now. And I think it's fine. Like, anybody seen any issues? So, and then we run a bunch of other ones too. I listed them at the beginning. So we do the user service and the social graph one and a few others. I was using a dedicated cluster, basically. And I used one dedicated machine per instance. So if you want to do some benchmark runs, you have to do something like this. I started out with doing benchmarking in our production cluster, which means you can end up with any other services on the same machine, and then you have noisy neighbors and crosstalking and stuff like that. So basically, the numbers were completely useless. So I got this dedicated cluster, one machine per instance. All instances receive the exact same requests, so the exact number of requests and also the exact same request, right? Because it matters if a tweet is just 1 character long or 280 these days. That makes a difference. So exact same requests. I've been doing this with the JVMCI 0.30 and Graal 2.22, which is kind of old now, but it's still, performance-wise, it's about the same. And we are doing tiered still. Yeah, there's not much to say about this. Maybe one thing to say about this is Graal, again, is written in Java. And since we run on 8, in 9 it would be different because 9 would have AOT, but 8 doesn't have AOT. So you have to bootstrap Graal in a way, right? If you start running and you start to compiling with your top level tier, while it compiles your application method, it has to compile itself too. It's kind of a meta-circular thing. And in a tiered setup, the way it's configured by default is that Graal itself is only compiled by C1, not by Graal itself, because that would slow down the whole compilation process. So that's why we run in tiered. Yes, bootstrapping, what I just explained, is for most of our services not important because they don't, we do frequent restarts of our services, but we do rolling restarts, so it's not that important. If the service starts up, I don't know, I'm making up a number, 5 or 10 seconds longer, doesn't really matter. So never seen an issue with that. And AOT would solve that for us in 9. So this is 24 hours. It's just to pick the random day. It was September 10th. You see there's no y-axis, and there's a reason for this because I'm not allowed to show you actual numbers. But we'll get to some ratios later, and then you'll see. This is really to just show you that all of the configurations just receive the same number of requests. I use that graph to make sure that they're actually running and all the routes are set up correctly and they're actually getting all the load. So we're doing C2, we're doing Graal. I also throw in there JDK9 to show you that it's the same, right? So if you could download JDK9 today, as I said earlier, try it out, and you get the same. The first one is, so this service, the tweet service runs parallel GC. That's why we're seeing scavenge cycles here. So that's C2, that's the scavenge cycles. It's a moving average of 60 to kind of smooth it out a little bit. So that's how it looks like. With Graal, it looks like this. So number one, we're doing less GC. And that's because escape analysis is better. So we can escape analyze more. That means we don't allocate as much memory. We don't have to collect as often. And it looks, that C2 again, it's about the same, and the same with 9 as for 8. So there's no difference. About 2.5% less GC cycles. It's not that much, but it's something, right? If you don't have to do it, great. This is the old gen. I'm showing this because it's something that has come up with a couple of our service owners, because then they monitor closely how their services behave, right? And they look especially at CPU utilization and memory usage and things like this. So one thing that is certainly different is Graal uses more old gen, slightly more, and also metaspace. And the reason for that is it's Java code, right? It has to. It has some state. Graal has some state. It doesn't have a lot of state because compilations are basically stateless, right? You compile a method, and you're done, and you throw everything away. But you have some state, and it's roughly 40 megabytes. And this won't change, right? It's always 40. It doesn't matter if your heap is 200 megs or 20 gigs. It doesn't matter, right? It's just the state Graal has. And the metaspace usage, I didn't have a good graph for that, but the metaspace usage, I think, is like 20 megs, if I remember correctly. It's just the additional classes you have to load in for the compiler itself that takes up the memory. So this is the important one, right? CPU time. That's the one at least I care most about, and the one that I wanted to bring down. And this is what it looks like. I know it's still hard to tell how much that is, but you can clearly see it's less. And this is C2 with 9. I'm not exactly sure why it's actually better than 8. I don't think there was any optimization in it. It just sometimes, because C2 as well as Graal heavily depend on profiling information gathered during the run, and sometimes inlining decisions fall either side. So if you do a rerun of the same benchmark, it can be just a few % faster or slower depending on inlining decisions. That's just how it is. Not in this case, it's basically exactly the same. So if I put it in a ratio, then I can show you actually a y-axis, right? Then it kind of makes sense. And as you can see, that's quite a lot. So we save roughly 11% of CPU by using Graal instead of C2. So how much money is that? Well, I can't tell you. Well, obviously. If I can't even show you a y-axis, why would I be allowed to tell you about money? But you know, we can make some stuff up a little bit. So just to get a feel for it, how much could that be? So I was just Googling some cloud hosting providers, and these things popped up. I've never actually used one, so I don't know if these numbers are actually reasonable or not. I don't know. Anyway, if you calculate it out, it's like between, what, $85, $72, and $210, right? So if you ever use one of these, choose wisely. On an average, it's like $127 per year per CPU core, roughly. You know, let's just pick a number. I mean, internally, since we are running our own data centers, we have a number like that too, right? How much dollars is one CPU hour or something like this? And I don't even know if it's close or not, but you know, it's just for the sake of an argument. So how many cores? I found this article from 2014, which is already 3 years old, where the article says 2 million servers. Well, anyway, so a lot. That's basically what I want to say. Your company is probably not as big as Google or Amazon, but you might have, I don't know, 10,000 servers. Could be. I don't know what you're running, but let's just pick a number. Let's say 10,000 servers. I can tell you, I think I can say that Twitter has more than 10,000 servers. And they usually have like 24 cores, so let's say, okay, we take that $127, say, times 24 cores, times 10,000 servers, is like, you would have to pay $3 million per year to run your business. If you could save 11% of that, you could hire 1 or 2 engineers. Well, I don't know what the salaries are here. 11%, I mean, that's huge, right? I mean, ask Volker, if you work on compiler technology and you want to improve the compiler, you're usually going in the 1% area, right? And then you're already excited if it's 2. But 11 is just outrageous. But can we get a little more? Well, maybe. Well, actually, yes. I was just toying around a little bit. You know, Graal has some parameters you can tune. It's mostly about inlining. And so I did that for an afternoon I really didn't do a lot. But this is the same slide as before. And then I added just one more called experiment. Same number of requests, dedicated machine. This is the slide that we saw before, and this is the experiment. So it's slightly better. That means, I don't know how many of you know how escape analysis works, but it heavily depends on inlining. If you can inline more, the view of the compiler is greater, and so it can escape analyze more. So this is what's happening here, right? I tuned inlining, and so I made escape analysis to work better. And we could reduce again the scavenge cycles by 1.5%, roughly, in a high load scenario. And CPU time was also slightly better, which was expected. So we got another 2%. And I was just, I was doing this for maybe 2 or 3 hours one afternoon. What do you really want to do? And someone else on my team is actually doing this. We're setting up something called AutoTune. And what it basically does, it's a machine learning system that you throw JVM parameters at, and then it just figures out what the right parameters are, or the most performant ones, let's put it this way. So that's something you really want to do, right? You don't want to sit there and change the parameters manually and then run it for 2 hours and see if it's better. You want to kick off some machine learning stuff and let it do it for you. So someone else is working on this, and we've done some talks about that. So I forgot to link one, but there's something out there. So official support is, I guess, important for a lot of people. If you have your business, and I guess some of you have your own business or you work at a company, and I'm assuming you don't have your own JVM team, so you don't have your internal in-house support. So official support is definitely important. So JDK 9 contains Graal. It's not really advertised, and it's definitely not supported in the Oracle supported way, but it's there because AOT uses it. So if you want to do AOT compilation on Linux, it needs Graal, so it's there. And this is the undocumented way of running it as a JIT compiler. You just turn on JVMCI, and then you tell JVMCI use it as, or use the JVMCI compiler. So do that. Download 9 and use this. And also, when I wrote these slides, it was before Oracle announced that they're open sourcing everything. But this is still very, very interesting. So there was this very innocent looking review happening on the mailing list sent out by Vladimir. And it's basically about building Graal regardless of AOT. Right? I thought, okay, yeah, whatever. But let me zoom in on this a little bit. So what he says, I'm not even sure if he was allowed to say that, but he just did. They're planning to have Graal as an experimental JIT compiler on Linux in the next release. And when that happened, they still were on the JDK 9, JDK 10 release train, not the 2018.3 one. But I'm thinking that the 18.3 release might be the release he's talking about. It's still experimental and not supported, but it's much more supported than it was before. And just the direction where they're going tells us, okay, they're serious about this, right? I've been talking to people about Graal a lot, and usually the question I get is, yeah, we don't know what Oracle's going to do. Are they really serious about this? I don't know. I don't work for Oracle anymore, but from all I heard, especially at Java 1, yes, they are. So try it. If you go into the office on Monday morning and you have stuff to run, maybe you run some Scala code, give this a try, because you can seriously save a lot of money with that, depending on the size of your business. That's it. Thank you. questions?
So your numbers all refer to Scala code, right?
That's correct, yes.
Okay, so do we have some numbers for pure Java code?
So basically 95% of Twitter is Scala.
Okay.
I don't have a good way of testing Java code with that. We have like a handful of services that run on Java, but it's not as easy to run them as the other ones because there's the odd ones out. From all I know is that the improvements we are seeing here, you probably won't see with Java. You won't see 10. And it's just the way Scala is compiled. It's like I talked to Tom Rodriguez about this a little bit. If they looked into the differences between Scala code and Java code. And what he thinks is that it's actually the polymorphism in Scala where Graal shines, because the way it does inlining is differently. You know, C2 does it at the parse level, while Graal does it at a later stage. So he thinks it's that. But you might see an improvement with pure Java code as well. You might not.
So one comment and one question.
Yeah.
Comment is following up on the previous discussion. The fundamental typical difference between Scala compiled code and Java code is that Scala tends to do a lot more short-lived allocations because of the way that the whole collection framework is built.
Yeah.
So it makes sense that better escape analysis would actually figure into it. But just a comment. I was curious about, you mentioned that you tweaked sort of the inlining parameters a little bit to try to get more mileage out of the escape analysis. I was wondering if you could share a little bit of detail about what you did there.
A comment to your comment. It's true, yes. But what I found is it's not that important. I'm running an experiment right now. I didn't have time to put it in the slides, but when I turn off escape analysis, we still see like a 9% improvement or 10. So for this particular service, it's not the short-lived objects. There's a difference, yes. There's a 2.5% difference as we've seen in the garbage collection reduction, but that's about it. To your other question, so there are a few knobs that you can. So the inlining, how should I put this? So inlining in C2 is very finely tuned, right? No one really wants to touch it anymore because it has been tuned over the last 15 years and it works great for everybody. And the way inlining works in Graal is similar, but it's smarter. It still has hard-coded heuristics, and these are the ones you can tune. And it's the typical ones like how big can a method be before I'm not inlining it because I know it will be too big anyway. So things like that. I don't think there's how deep you can go. There are like 3 or 4 you can easily tune. And I was just going, one of them has like, I forgot which one it was. It has a default value of 200, just to throw out a number. And I was going from maybe 100 to 300 and see how that goes. So I did a little bit of that. I basically increased all of them slightly. That's where I got more being inlined, and that's where escape analysis could work better.
35 byte codes, it might be 60 or whatever.
Yeah, something in that order, yeah. Like I increased it by, I can't remember, like 30, 40% or something like this. It was, as I said, this shouldn't be done manually, right? The computer should do this for us. Way in the back.
So you tested GeeCON 9 Graal version.
Yes.
There is a version on Oracle Technology. There is a version on Oracle Technology Network that we publish as well. Do you have results for that? Because it should be faster.
So the JDK 8 one, that was Graal 0.22. That's basically from GitHub. Oh, you're talking about Enterprise Graal.
Yeah, the OTN contains enterprise.
Yeah, well, Yeah, that's a whole another talk. I mean, I can briefly go into this because you're here. So there's the open source Graal version that I talked about, which you can download from GitHub, and there's also something that Oracle Labs is working on. It's called Enterprise Graal, which is an add-on to the open source version, and you get better performance because it, as far as I know, you might correct me, it does better inlining, and it has vectorization support. When I use that, I've done this in a previous talk. When I use it with this tweet service, where I see 11% improvement, with Enterprise Graal we see 22.
Yeah, basically I'm asking because if you see 22% with Scala, you should see something like 10 for regular Java code. At least I hope.
That would be great, yeah. I'm not sure if it will be 10, but with Enterprise Graal, you should definitely see an improvement with regular Java code, yes. That's true. It's just not free. Yeah, you shouldn't say anything. Oh, it's the tweet service. It's getting dark traffic. Like it's basically read only, right? It gets only the tweet read requests, like they would happen in production. I'm not really doing any benchmark. That's why I look at the CPU utilization and not the number of requests being served, right? They serve the same number of requests, and then you just look how much CPU did you use for that. Any more questions? All right, thank you.